I am one of the people at Continuum who builds packages, and I also work on the tooling at Continuum to build packages. And I was going to come here and tell you guys today about all the stuff that goes wrong with packaging. And in talking with some of you in the hallway, it really became clear that it would be better if I just showed you how to do packaging from the get-go and not show you all the squirrely stuff that can happen that makes my life fun. So we're going to talk about kind of the anatomy of a package and how to start one from nothing. And then I'm going to show you Conda Build, which is the tool that I work on to help make some of this stuff easier. And if we have time, I'll show you guys a little bit about what we're doing at Continuum to try to automate our builds and make it scalable. We currently provide about 700 packages, but PyPy has about 80,000 packages. Of course, that's a really long tail of packages that don't get used. But keeping up with the ecosystem is a hard problem, and it's something that we're working on. And we won't get to the squirrely stuff. I'm sorry. So you want to make a package. Let's talk first about what exactly a package is. What I'm going to call it two different things. Most of the time when I'm talking about a package, it's some kind of file that you're going to ship around that has stuff that you want people to be able to install. Some kinds of packages, like Python packages, are files, but they have formalisms to say where the files should go so that Python knows what to do with them, right? There's also the term a Python package, which means like a folder that has Python modules in it. And that name overloading kind of, yeah, it's unfortunate. So I'll try to be clear here where I'm talking about package types as files. And if you have package files, you might be familiar with sdis or wheels. Those are things you'll see on PyPI. I deal mostly in Conda packages, which are a .tar.bz2 file that has a particular layout. And to produce one of those, you always start with, well, if you're dealing with Python, you start with a Python package. And so who here has made their own Python package? Anybody? A few people. Did you use a standard layout you found somewhere, or did you just kind of wing it?
Use a tutorial.
Yeah, tutorial. Tutorial's great. This might be even better than a tutorial. So cookie cutter is like a template generator thing. And I'll just show you their website. It's a Python installable library. And when you install it, you can then run a cookie cutter for any given kind of project that you're going to start. Okay, so if I go over here and I start a real quick Docker container that just has Miniconda installed, I can just say pip install cookie cutter. And then cookie cutter. I'm going to go to one of these, to a particular repo I have here. Oops. So we've made this particular template for Conda projects. And so it just goes through this interactive dialogue. Is this, I can make this bigger. Is that big enough? You go through this interactive dialogue, you say, oh, my name's Michael. And email address, whatever. GitHub username. And this is filling in blanks in that package template so that what you get out is now this llama folder that I've created that has that nice standard layout you would get from a tutorial. And if you take a look at what's in setup.py, it's kind of set you up for just kind of a generic thing that you can build on. Okay, so if you have existing code, this is still useful. It's kind of showing you the model, and you can copy and paste stuff into this model of stuff. All right. To actually build a package with this, you can just say, I think it's pip wheel dot, right? And so that just built a wheel for my package there. Similarly, because this Conda, this particular cookie cutter template of ours is made for a Conda recipe, what's in that conda.recipe folder is a meta.yaml file, which is the input to conda build for us to build a conda package. So I can say conda build, conda.recipe, and it's going to tell me I don't have conda build installed. Not a problem. Conda install, conda build. And if we do that now, so what you'll notice is that conda build is going to have a whole boatload more output. And it's because conda build is a more complicated tool. What it's doing is it's leveraging conda's ability to create environments, and it's creating the build environment for the package, and it can create any number of different configurations. So it does that, it runs the build in that thing, it then detects what files have changed in its build prefix where it's created the environment. That's what it kind of considers as files to package. And after that, it runs a test phase where it installs the package that it's created and makes sure that it works for you. Okay? So compared to wheels, conda recipes and conda packages are totally language agnostic. It is totally all about this, this Unix kind of file system layout. And so the output package here goes to the mini conda, conda build Linux 64 folder here. And if we take a look at what's actually in that, that file, we've got a whole bunch of metadata that tells conda about what's going on in that file and how to deal with it. We've got the Python files that got recorded and pre-compiled for stuff. And then we've got the entry point. But you see this is very imitative of something that you would see as like /etc, right? /etc lib /user whatever. That's kind of how it works. And the fundamental key to a conda package is as long as you kind of it will create the build prefix. As long as you move stuff where you want it in that build prefix, it'll get packaged. And so if you've ever fought setup tools to include files outside of Python, setup tools is great with dealing with Python files, but dealing with like data files, it has caused me great pain. And in comparison, a conda recipe lets you just simply move something into that prefix file. And so if I say here, go back to my recipe, and apt-get install vim. Yep. So this part doesn't have this does have the build instructions in it. If I comment this out, I can also have a separate file that then can do anything. And so we can say echo llama. And then there's a few important predefined environment variables. So $prefix is going to always point to that build prefix, or if it's in the test environment, it's going to point to the test prefix. But this is all you need to do to actually install files into a conda package and have conda know what to do with them. Okay? So we've seen a conda build. I'll skip over that. One other quick and easy way to create conda recipes is we've made skeleton generators. And so we know that there's these other repositories that have boatloads of really great content on them. And we want to make it easy to bring those into the conda ecosystem. And so I'm going to go ahead and create a skeleton here for Beautiful Soup 4. So I know it's on PyPy. If I say Beautiful Soup 4 here, this is going to go look on PyPy, get the metadata, read the setup.py file information from that file, and come up with a recipe for us. And so here's our folder with the recipe in it. And we've got that build.sh folder and meta.yaml. Build.sh a lot of the time is really nothing more than just saying Python setup.py install. And if that's all you have, you can roll that into the meta.yaml, which is what I showed you guys before from our template. But you see here, it's just gone to PyPy, recorded all that information, gets you the MD5, and it makes your life a whole lot easier to start out from something from PyPy. Okay, so we've got the same thing for CRAN and CPAN, and we just recently added support for RPMs. If you need to, what we're moving towards more and more is having really low-level system packages, and so people had been moving towards building things like X11, and it's really hard, and it ends up giving you like really poor hardware acceleration capabilities. So what we're trying to move towards instead is to encourage people to rebundle the operating system level packages and use those as they see fit. All right. What I've shown you is a gross oversimplification, and if there's ever been a part of programming where there's been more edge cases, I haven't seen it yet. So every given package takes special love, especially when you have compiled content in there. And another big thing is how do you keep all of your dependencies in line? How do you keep them compatible? So you don't want to be too restrictive, and you also don't want to be too loose with your constraints. If you're too restrictive, then you unnecessarily mean that other packages can't play nicely with you. And at the same time, if you're too loose, things can change out from under you and your software breaks. So I'll show you guys a little bit more about that. We've added a new feature in our latest version of Conda Build that's really exciting. Once you have your own package, there's a lot of different places to put it. So everybody's probably familiar with PyPI. Who knows about anaconda.org? A few people. Yeah, so anaconda.org is Continuum's community repository. People get free channels by themselves, and you can put your own packages there as much as you want. So unlike PyPI, where somebody can kind of lay down a claim to a package and kind of have this namespace battle of who is the actual owner of a package, it doesn't matter on anaconda.org, right? You are you, and anybody can install from your channel, and you manage what's there. So yeah, I've found it very refreshing, and what has really been incredible to see is the community that has grown around anaconda.org. So people have recognized how powerful that kind of ability to have your own channel and your own really purpose-built channel is. And there's been several communities of people who have come together, and they each have their own way of building packages, but they end up uploading them to anaconda.org. So Bioconda does all kinds of biology-related stuff, DNA sequencing and stuff I don't understand. Omnia was molecular dynamics, Menpo is computer vision. And so what this means is that even if Continuum doesn't have a package for you, you can say Anaconda search what you're looking for, and a lot of the time somebody on one of these other channels will have built it, and that's pretty awesome. The biggest community by far is one called CondaForge, and this has been just a unifying effort. So they have a really nice CI type setup where you submit a recipe, it builds, tries to build a package, and when your PR is merged, it becomes part of this giant aggregate repository of other recipes. So I would really strongly encourage you guys to check out their website, and also if you're using Conda and you can't find a package, the first place to look is CondaForge. As I said, we've got about 700 in our repository. They've got 2,600, and they're growing fast. And we're a part of them, to be honest. So we have I participate in CondaForge, and we have 2 or 3 other people that help with it. So it's really nice to see that grow. One other, I guess, kind of silly, fun trivia thing to show you. Here, this is what I wanted to show you. I'm pretty sure this is the organization on GitHub with the most number of repositories. Because what happens is every single recipe becomes its own repository. And so this organization has 2,644 plus a few repos on it. And that has a consolidated view that gets automatically generated once in a while called feedstocks. It's all corny and blacksmithing themed. But yeah, so you just see here, these are all submodules, and GitHub refuses to show you anywhere close to all of them. So when we started seeing this, it was a fun day. So I mentioned that there's a lot of ways that things can break. There's some things we can control as packagers and a lot of stuff we can't. And so when it comes to these three things, API is the actual code in a program. And that's, people may change arguments, they may change return types, they may change input types, all kinds of stuff. That's obviously going to break you. ABI is more subtle. That comes about due to like what compiler you use or what OS you're on. When you build something, you get these binary symbols that may or may not be supported on other people's computers. Who has tried to install TensorFlow from PyPy and had it not work? Okay, this was your problem because Google was evil when they published it, and there is a standard for publishing wheels on PyPI for Linux. And that standard says that you have to build your compatibility back to this old OS, CentOS 5. Now, they did not do that. They built on a newer system, and they did not make it compatible, but they labeled it Many Linux 1 compatible anyway. So give them a hard time if you see anybody. Yeah. Finally, constraints are both a way to make stuff work, but they're also a way to make it break. So they are the part that we really have control over to help make sure that things work. As far as ABI compatibility, it's boring. There's not a lot of secret to it. It's just a matter of laying down good standards of what your worker machines are going to be and understanding the limits of those worker machines. And yeah, the hard part is that those worker machines, it's really hard to make everybody happy. Because you've got some people in your organization who stability is the ultimate goal and we have to stay on CentOS 5. You got other people saying, I want to use C++ 14. How do you do both? It's hard. And the answer is not always good. So on Windows, it's really boring. We just follow upstream. And so upstream says Python 2.7 is built with Visual Studio 2008. That's what we do. And as a result, we can't support things that are done with C++ 11 for Python 2.7 on Windows. So in that case, we sometimes patch packages to remove C++ 11. There's some idea, it's been like a really hotly debated thing to build Python 2.7 with a different compiler, but it's really hairy and there's really not much support from upstream. So that doesn't seem like it's going to happen anytime soon. macOS is boring. Also, you use the right SDK. When it comes to Fortran, we ship GCC packages that also include gfortran. And that's just a little bit tricky because Clang++ is not binary compatible with G++. Yeah, good times. Linux is finally the most interesting. And we've gotten really, really far by building on CentOS 5 with the newest compiler that was available there. So if you've used Anaconda for the past 3 or 4 years, this has been what it's been built with. Now, this is also, the Many Linux people kind of reverse engineered this, and this is also their standard. They build with a slightly new compiler I'll talk about in a bit. But we really hit a lot of problems with this because we're not getting any of the performance or security improvements that have come out of newer compilers. So what you really want to do on Linux in order to build a package that's as good in terms of compatibility and performance as it can be, you want to build on as old of a Linux distribution as you can tolerate. And so For example, where you cease to be able to tolerate it is where the kernel symbols have changed too much, and you start to have trouble with stuff that builds against the kernel symbols. TensorFlow, for example, don't try to do it on CentOS 5, which is coincidentally why Google didn't try to do it on CentOS 5, right? Yeah. For those of you guys following along, this is the most fantastic website describing what you should do for this process. That's got the reasons why it works, and a very, very good article. So really what you want to be able to do is custom build your own compiler or pull one in from somewhere else that's newer and use it on an ancient OS. So the many Linux guys have a Docker image that does exactly that. They use CentOS 5, and they have this Red Hat Dev Toolset compiler that's specifically patched a lot by Red Hat to maintain this backwards compatibility. This is also what CondaForge uses. One of our experts, Ray Donnelly, who's famous for doing a lot of the MSys2 project, he just doesn't trust that, and so we're kind of wary of this. We don't have any hard evidence against anything. He's just queasy about it. So we tried to custom build a new GCC into a CentOS 5 Docker image. I did GCC 5.2. And it just had too many strange issues, and I tried to make it multi-lib so that a 64-bit compiler could compile 32-bit code, and nobody was really happy. Anyway, what we're doing now is we are making Conda packages for the compilers. These are built with a tool called CrossToolNG, which is the absolute coolest tool ever for creating portable tool chains. It includes both the kernel headers and glibc or muscle libc or any other libc you want. And because it encompasses all of those things, it no longer matters what build platform you're on. So it gives us really tremendous freedom to use whatever other build platform is convenient for any other reason. And it comes at the cost of we need to ship libstandard C++. People have to use our libstandard C++ because our compiler is so new. So libstandard C++ is totally backwards compatible, but if you build on too new of a compiler and you have an ancient libstandard C++, you're going to have these binary symbols that then aren't available. All right, you can imagine this has caused a lot of headache to people over the years, and it's been wonderful that our platform has been so standard for a long time, but because people are wanting to change and wanting to adapt to newer compilers, we have to figure out a way to solve this. And it really comes down to the information's there, you actually have to record it, and you've got to use it to make decisions. So our term for this internally is CDT, stands for Core Dependency Tree. And Conda Build's going to start recording this kind of stuff. It's just all the information related to the compiler that was used for your system and all the stuff that's going to affect its bounds of compatibility. And then more for informational purposes, things like the compiler flags. All right. What Conda will do with this is, because it's embedded in the Conda package itself, you will be able to specify to Conda or even have Conda detect what your system is compatible with. So if you're saying, oh, I'm on a CentOS 6 system, I cannot use anything that's built with a glibc newer than 2.12. And Conda can then make recommendations to you to say, oh, well, you know, this package is uninstallable because this. Or it can also say, oh, you're actually running a new OS, and we can turn on these extra optimizations. So it's going to give us a lot of flexibility to make things work better. When it comes to you guys writing recipes, just a tiny bit of advice. Avoid constraints as much as you can and keep your recipes as general as you can. And so what I see a lot of the time is, especially people coming from the pip world, writing requirements.txt files with exact pins. Exact pins are fine as long as you're creating an environment. But if you are installing two packages with two separate requirements files, and they each have different equals equals constraints, what do you think happens? it should blow up, but it doesn't. pip has actually really strange rules, and it's kind of like the first one in wins. Yeah. So we just released Conda Build 3 this morning, and this has been about a year-long effort to cram Jinja 2 into as many corners as I could into Conda Build, because what we allow through templating is we allow all of that pinning stuff to be done dynamically and later and from external sources. So something like CondaForge can have a canonical copy of a recipe that doesn't define any versions at all, but then somebody else can define a separate outside file that maps their own CDT or whatever you want to call it. So there is an IPython notebook I'd like to just run through real quick with you guys and show you some of the new features here. This is also a blog post that's gone out this morning. If you want to look at it, check Continuum's developer blog page. And what this is going to show you is Conda rendering, which means it takes that input meta.yaml file and then does stuff to it, fills in templates, does the selectors, which are running particular lines or not. And I'll show you just the extra flexibility here. So this is the Jinja template syntax for, hey, it's a variable here. And I've got my config file that is just dead simple YAML, and it's a list of values. And what's going to happen is Conda Build is going to put in those values for each of those template things. So here it's rendering what the actual output files would be. And here's what the actual recipes would be. So you see it's done the pinning. Okay, kind of cute. So this works for Python versions, it works for NumPy versions, it works for anything. One thing I'll point out about Conda Build is it really tries to enhance reproducibility. And so what it's doing when you render a recipe to build it is it's saying exactly what was in the build environment, so that you're able to then rebuild exactly that recipe based on whatever was in the past, even if there's new versions of stuff that has come out since. Yeah, if you guys, I'm going to skip that. That's just saying that the old way of doing things still works. But, well, the other interesting thing is whatever you build has this new thing. It looks a lot like a Git hash, because it, for all intents and purposes, is kind of a Git hash. It is formed by all kinds of important information about your recipe, and what it gives us is the ability to differentiate those variants on disk in a totally generic way. And so the old way was to say, oh, well, it's Python, and so when you have Python, that gets added to the file name somewhere up here, right? You get py27, np, whatever. That does not scale, right? What if you have gdal1 and gdal2? So that's what the hashes are for. And then there's a way, which I skipped over here, to have it tell you what actually went into that hash, because it's pretty obscure, right? H whatever doesn't tell you anything about what went into it. So this is kind of primitive at this point, but it's the kind of thing where we can probably build a library query tool to say, tell me all the packages that meet this condition, right? One other thing is we've enabled pinning to be relative. And so what you would see in a requirements.txt file is just simply some text. And what you see now in Conda Build is it's going to say, what version of libpng did I have at build time? And let me express some constraint based on that version. So the way that this works is there are default arguments to it. So if I just say pin compatible to libpng. It's going to look for libpng up in the build requirements. And here it's found, oh, look, I had version 1.6.27. The default way of doing this pinning expression is as many places of precision as you have in the version number for the lower one, and then the next major version. So this is totally customizable. You can change the max pin to be like 2 places, right? And then it increments that last place. You can also get rid of them or specify exact values. And so if you specify any of them as none, it's going to say we'll just leave that constraint out completely, so we have no min pin. And if we say the upper bound is 5, that totally overrides any of the relative pinning. One other thing that's really key to Conda Build 3 is we want to enable people to use dynamic compilers and dynamic compiler settings. And so if you move away from the thought of like, oh, I need a compiler configured on my system, you don't. You just need to tell Conda Build how to get a compiler or how to set one up. And so if you're using these MSVC things, Conda Build has in the past run the activate script for you. It'll still do that if you want, but what we're moving towards is you will make a package or you will use a package that explicitly defines your settings. And this is fantastic because people will be able to just, so Intel, for example, is really excited. They want to use their Intel compiler to build all this stuff, right? But they don't want to hack that into Conda Build. Now they don't have to. They just have to use recipes that are built for this compiler metadata and then configure in their Conda Build config.yaml what the exact compiler is, and that's it. So it's just tremendous flexibility. And yeah, so there you see it's rendered in different compilers. One other kind of cute thing, and then I'll be done here, is that people oftentimes forget or don't know what their actual dependencies are. And so what Conda Build 3 frees people up to do is it frees up the pinning, the actual addition of the constraints to the package creators, to the upstream package creators, rather than the downstream person using the package. And what we're hoping this is going to iron out is a lot of missing dependencies on shared objects at runtime, and especially libstandard C++, because people are really used to that one being on the system. So anyway, we've got a recipe. It's doing this thing called run exports, and it is exporting something compatible with whatever we have at build time. And we also have a recipe that's just going to use that. And we're going to build the first one, keep it here locally. And when we see what would be fully rendered for that second one, it has inserted that new bzip2 requirement based on using this package has run exports here. So really hopeful that'll turn out. If it blows up in our faces, there is a way to turn it off. So please play with it, and I'd be very curious to know what you think. I guess I have a little bit of time for this. We have not had a CI system for packaging, and so we script everything, of course, but it requires us to like SSH or VNC or RDP or whatever into some build worker and build stuff. And that manual tedium is just terrible. So we've set out to create a CI system, and we need it to be cross-platform. We want people to be able to volunteer machines as workers. And we also want this thing, we've got hundreds or thousands of recipes. We can only build what changed. We don't want to build the whole system all the time. That's totally intractable. And that's what has killed earlier efforts. So we experimented with a lot of CI tools and settled on Concourse CI, which was started by Pivotal. The really great thing about this is it's totally based on YAML files, and that you can dynamically create pipelines from pipelines. And so our process somebody will commit recipe changes. And then we have a job on the CI service, and this is kind of the static job. It's computing what the build system should do, what recipes should be built. It submits a new pipeline, and that's what this looks like in Concourse. These are the jobs, nothing fancy, just it gets this stuff from up above and then runs the examination process and rsyncs the recipes elsewhere. And it creates these really cool looking build trees. And so this is kind of what goes into Miniconda. Yeah, thank you. This is what goes into Miniconda. It's just the basic fundamentals, but it's also Python 2.7 and 3.6 for just CentOS. As this thing goes along, things light up like Christmas trees. They go green when they're good, they go red when they're bad. But it's a lot of fun to watch, and it's also amazing because each of these things are totally separate processes and massively scalable, right? Each of those nodes can do a job, and so we're hoping that's a major boon for us. This is also much better at doing testing. So we've got a DAG. We can navigate that DAG. DAG is directed acyclic graph. To do much better testing. So we can say, well, whenever we rebuild NumPy, make sure you also test scikit-image, scikit-learn, whatever. Make sure that the core stuff doesn't break. So thanks. This is my team, and they're great. And thank you all for listening.
Thanks, Michael. Questions? Yes.
So I'm a bit new to Conda. I've been following it for the last 3 years or so, but haven't actually been using it until this conference. So my question was, it appears that the really compelling case for it is to be able to deal with binary and Python versions and compatibility across the systems, which is why I was attending this talk. I came away a little bit terrified from what I just saw. So is there anything that you can say that would help us understand the issues with regard to binary compatibility and stuff going forward? I'm not sure I'm coming away.
Tell me what terrifies you, because it's, I've certainly said that it's a lot of awful work, but there's never been a better time to dig into it, because Conda Forge especially is this monumental source of knowledge with really, really great volunteers who will help you sort through things. And so if you submit a recipe to Conda Forge, you will absolutely end up having it work and learning a lot.
Okay, so basically it's really the community we've got this really dynamic, good community that we've known and loved for years here, and that's going to help me be able to go ahead and use the system to be able to deal with these problems? Or?
Well, I mean, the technical issue of binary compatibility is one that's not new at all.
Yeah.
Right? This has not changed. And the only thing that's making it harder is that we're kind of at a crossroads where C++ 11 and 14 have improved the situation enormously, but they require modernization of your stack. And there's just rivers you've got to cross.
Fair enough. Thank you.
Oh, one up there. Get my exercise this way. Thank you.
Question about missing dependencies. So I saw there's kind of this clever idea of picking up whatever is on the machine at build time and then generating your dependency file based on that. It wasn't clear to me how you knew which dependencies actually mattered and which were noise.
So for reproducibility, I would argue that they all matter. You want to be able to recreate the same package at a later date, and I think it's an intractable problem to say, I want to figure out which one of these really matter. So am I actually linking against bzip2, or is that a trivial thing that Python's bringing in? I don't think it's worth the effort.
Got it. So there's no static analysis or anything. You're literally just saying, hey, anything that's on the machine, on the build machine, could affect the final product, so let's just take it.
Not quite. Okay. So it's not on the build machine, it is the build prefix itself. And so it's to say, I ask Conda, hey, here are my specs. what are you going to install for these specs for the build environment?
Got it.
Yeah, if you ever get system stuff in your package, you're going to have a bad time. And so that's one thing that Conda's really pretty good for is the system isolation and keeping your packages pure. And that means you're more confident that they're going to work on the other end.